Consider a solenoid connected with a battery. When the switch of the battery is closed, a current I flows through the solenoid. And when current flows through the solenoid, it produces magnetic field around itself. The magnetic field strength produced by the solenoid is equal to, that is, mu naught Ni. Mu naught is the permeability of air medium. N is the number of turns of the solenoid. I is the current that is flowing in the solenoid. Again I am saying, when current flows through a solenoid, it produces magnetic field around itself. Because I mean discuss करते when current flows through a solenoid, it acts like a bar magnet, producing magnetic field around itself. The magnetic field strength is given by this mu naught Ni. So let us again start from the beginning. When current is allowed to pass through the solenoid, the current flows in the loops of the solenoid. So when current flows through each loop, it produces magnetic field lines. It produces magnetic field lines. More is the number of turns, more is the number of field lines produced by the solenoid. So that means, so again, the current flowing in a loop of the solenoid produces magnetic field. More is the number of turns of the solenoid, more is the magnetic field lines produced by the solenoid. So that means this term Ni produces magnetic field lines. So this term Ni is represented by H, that is magnetic intensity. That is called magnetic intensity. More is the amount of current, more is the intensity, or more is the number of field lines. More is the number of turns, more is the number of field lines. So that means this term Ni is called magnetic intensity. It is represented by H. So when these magnetic field lines, when the magnetic field lines are produced, they will move through the medium. They will move through the medium. So it is the medium which allows these field lines to pass through it. That is called permeability. That is called permeability. So if the field line is traveling in the air medium, it is called mu naught, permeability of air medium. Again I am saying, the solenoid produces magnetic field lines. These field lines will travel through the medium. That is called permeability of the medium. More is the permeability, more is the number of magnetic field lines allowed by the medium. Less is the permeability of the medium, it will allow less number of magnetic field lines to pass through it. Mu naught is the permeability of air medium. यदि हमें solenoid को air medium रखुचे, then it is the permeability of air medium which allow these field lines to travel through it. Then our ratio, that is magnetic field strength. So we can say these field lines traveling in air medium is B. Magnetic field strength. First is magnetic field lines produced by the magnetic field lines produced by the solenoid. They will travel in the medium. So they are traveling in air medium, that is called permeability of air medium. So when it travels, that is called magnetic field strength. Okay, so let us say, since it is since it is moving in air medium, let us represent it by mu naught. ठीक है. So then let us take a a magnetic substance. Let us take a magnetic substance. And आम्ही जाणीचे in a magnetic substance there are dipoles which are randomly distributed. North south like this. So let us place this magnetic substance in this magnetic field. Let us place this magnetic substance in the magnetic field of this solenoid. So that means when this magnetic substance is placed in the magnetic field of the solenoid, so these dipoles are aligned, or it is this magnetic substance is magnetized. It is magnetized. Magnetized means these dipoles are aligned in the same direction. North south like this. ठीक है. So this magnetic substance is magnetized. Magnetized means these dipoles are aligned in a particular direction. So this alignment of dipoles in a particular direction is called magnetization. And I is called intensity of magnetization. Intensity of magnetization. It is called intensity of magnetization. This intensity of magnetization is the number of dipoles aligned in a particular direction per unit volume. Again, I is the intensity of magnetization. It is the number of dipoles aligned in a particular direction in a given volume. More is the number of dipoles aligned in a particular direction, more is the intensity of magnetization. Again, this magnetic substance when placed in the magnetic field, these dipoles which are randomly distributed before in the magnetic substance, they are aligned in a particular direction. That is called magnetize or magnetization. The process is called magnetization. So I is called intensity of magnetization. That is the number of dipoles that is aligned in a particular direction in a given volume. The more is the number of dipoles aligned in a particular direction in a given volume, then more is the intensity of magnetization. So when the magnetic substance is magnetized, तो तारा कौन होगा? It will have its own poles, that is north pole and south pole. ଯେତେବେଳେ ତାର ନିଜର poles ଆସିବ, it will produce its own magnetic field. It will produce its own magnetic field, that is like this. The magnetic field length is from north pole to south pole outside the magnetized magnetic substance, and from south pole to north pole inside it. The magnetic field strength of the induced or magnetized magnetic substance is, let us say it is Bm. Again I am saying, let us say the magnetic field strength of the magnetized magnetic substance Bm. तार वैल्यू कौन हो? तो एठी जेतले हम सोलोनॉइड नेले, the current flows through the solenoid. The current produces magnetic field lines. When the magnetic field lines come out of the solenoid, they move through the medium, air medium. So then there is a magnetic field strength. Then there is a magnetic field strength, that is mu into H. That is the magnetic field strength produced by a produced by a solenoid. So AT, the magnetic substance field strength is due to the magnetized dipoles, or the magnetized dipoles in a particular direction. Again I am saying, the magnetic field strength of the magnetic substance is due to the number of dipoles align in a particular direction, or that is I. So we can say this Bm is equal to, that is mu naught into I. Mu naught into I. AT found, that is mu naught into H. Because this current flowing in the solenoid or flowing in the loops of the solenoid produce magnetic field lines. These field lines travel through the medium, so there is a magnetic field strength. So AT, this magnetized magnetic substance magnetic field strength is due to the alignment of these dipoles in a particular direction, that is I. So we can say this Bm is equal to mu naught into I. We have discussed that a solenoid produces magnetic field, and in that magnetic field जदि हमें गोटे magnetic substance रखिबा, तो then the magnetic substance will be magnetized. That means all the dipoles present in that magnetic substance will be aligned along a particular direction. ठीक है? तो आउट कथा हम डिस्कस भी करथिले. तो we are having three type of substances, magnetic substances. They are paramagnetic substance, ferromagnetic substance, and diamagnetic substance. This paramagnetic substance is attracted by the magnetic field or attracted by the magnet. So when we place this paramagnetic substance in the external magnetic field, or the magnetic field produced by the solenoid, then the dipoles present in the paramagnetic substance are aligned in a particular direction, like this order, south, north, south, like this. So that means it will have its poles after it is magnetized. So if it is magnetized, it will have its own poles and own magnetic field, that is from north through south outside and south through north inside. So that means when we place this magnetic substance in the external magnetic field, or here, so external magnetic field thibo plus magnetic field produced by the substance भी thibo simultaneously. So like this. So if you see, तो एठी magnetic substance भितरे magnetic field direction जोपाटे external magnetic field direction जोपाटे, किंतु बाहरे external magnetic field direction जो direction बाहरे induced magnetic field direction रो direction is opposite. देखो एठी, this is the paramagnetic substance. ठीक है. तो यार magnetic field कौन होगा, that is from south to north, like this. ठीक है. तो inside the magnetic substance, the direction of induced magnetic field is same as the direction of that is external magnet, that is like this. ठीक है, किंतु बाहर the direction of external magnetic field जो direction अच्छी तो induced magnetic field direction रो opposite. So that means बाहर since the two magnetic field are in opposite direction तो बाहर number of field lines will decrease, भीतर the number of field lines will increase. ठीक है, in this manner. तो भीतर the number of field lines will increase because भीतर कौन थिबो external magnetic field रो field lines plus induced magnetic field रो field lines. तो भीतर अधिका बाहर कम. So the net magnetic field strength inside this magnetic substance is B is equal to B naught external plus Bm induced, or that is Bm is equal to mu h and Bm is equal to mu I. So mu h plus mu I, sorry mu naught h plus mu naught I. ठीक है. If you see this ferromagnetic substance, these substances are also attracted by the magnet or magnetic field, but they are strongly attracted by the magnet. ठीक है, तो that's why paramagnetic substance जेमिति थिबो एठी मते सेमति, किंतु since they are strongly attracted, that's why they will have more number of dipoles align along the same direction of the magnet. So that's why we will have lots of magnetic field lines inside as compared to outside. Paramagnetic substances जेमती थिला it was the same thing as you. The net magnetic field strength inside this ferromagnetic substance is equal to sum of external plus induced. ठीक है, तो इटा जहाँ इटा मतलब same. So when you consider dimagnetic substance, so they are repelled by the magnet. They are repelled by the magnet. When they are placed in the external magnetic field, the external magnetic field यदि रखिबा, they are aligned opposite to the direction of external magnetic field. Again, they are the dipoles which are present inside this dimagnetic substance are aligned opposite to the direction of external magnetic field. So that means they will have poles in opposite direction. तो एटी कौन थिला, this is south north थिला, तो एटी कौन हो, that is north south, like this. north, this is south. तो magnetic field यदि consider करिबा तो भितरे कौन थियो, that is south to north, बाहरे north to south. तो भितरे external magnetic field direction and this induced magnetic field direction are opposite. This it hala external, it hala induced, they are opposite, but bahare they are in same direction. तो bahare कौन है जो the number of field lines will increase, but भितरे the number of field lines will decrease because भितरे कौन भितरे because they are in opposite direction. Like this diagram टा करिनी एमति रहिबो, बाहरे अधिक थिबो भितरे कम थिबो. ठीक अछि, like this. Okay, and this net magnetic field inside is equal to external magnetic field minus induced magnetic field, that is mu h minus mu I, that is mu h minus I, sorry mu naught, this is mu naught. Okay, it was the same thing, mu naught, this is mu naught. Permeability of air medium. ठीक है. The next term is magnetic intensity, that is H, or it is also called magnetic force. It I may just discuss करिथिले. When current flows through a solenoid, it produces magnetic field around itself. It produces magnetic field around itself. The current flowing in the loops of the solenoid produces the magnetic field lines. The current flowing in the loops of the solenoid produces the magnetic field lines. So this term is called, that is H, or that is magnetic intensity. When the field lines are produced, they move in the medium, that is permeability. If it is traveling in air medium, so it is mu naught, permeability of air medium. Okay, now after that, when they travel in the medium, they create magnetic field and they will have magnetic field strength, that is B. So this Ni is called H, or that is magnetic intensity or magnetic force. It is the field lines produced by the solenoid. So it that is mu naught into H. Okay. When they when these field lines travel in the medium, they will create its own magnetic field and they will have magnetic field strength. And after that, they will magnetize other substance. After that, they will magnetize other substance. Definition sheet e likha hai. Magnetic intensity is the measure of degree up to which a magnetic substance is magnetized. Next is intensity of magnetization. Intensity of magnetization is represented by I. এটা भी हमें discuss କରିଥିଲେ. When a magnetic substance is placed in a external magnetic field, हमें एक केस रे नहीं ଥିଲେ external magnetic field नहीं ଥିଲେ, that is magnetic field produced by a solenoid. ठीक है. When a magnetic substance is placed in an external magnetic field, the dipoles which are present inside the magnetic substance in a random order are aligned in a particular direction. And after that, they will have their own poles having pole strength. Then after that, it will produce their own magnetic field. The number of dipoles align in a particular direction of the volume of the substance is called intensity of magnetization. When the dipoles are aligned in a particular direction, they will have poles and pole strength. So ଯେତେବେଳେ pole strength ଆସିବ ତାଙ୍କ ଭିତରେ distance भी ରହିବ. Pole strength into distance is called magnetic dipole moment. So intensity of magnetization is defined as magnetic dipole moment developed per unit volume of the substance. Intensity of magnetization of a magnetic substance is defined as magnetic moment per unit volume developed when the substance is placed in an external magnetic field. Next is expression for intensity of magnetization of a bar magnetic substance. Again, this expression for intensity of magnetization of a bar magnetic substance. Let us consider a bar magnetic substance. When it is placed in an external magnetic field, so it will develop its own poles. So let us say when the bar magnetic substance is magnetized, let the pole strength developed is M. Let the length of the bar magnetic substance is 2L and A is the area. 2L is the length, A is the area. तो वॉल्यूम कौन होगा? तो वॉल्यूम इज इक्वल टू एरिया इनटू लेंथ. ठीक है. Again we know that this intensity of magnetization is magnetic dipole moment developed per unit volume, that is m by v. तो m is equal to pole strength into magnetic length, वॉल्यूम केते हबो एरिया इनटू 2l, तो 2l 2l कट रहला कोन, that is m by a. So that means intensity of magnetization is also defined as pole strength developed per unit area. Again, intensity of magnetization is also defined as pole strength developed per unit area. ठीक है, हेले pole strength रो यूनिट कोन हबो, that is ampere meter area meter square, ampere meter square. तो यूनिट केता हबो, intensity of magnetization in SI system it is meter meter कटला, तो ampere meter inverse. तो in SI system the unit of intensity of magnetization is, that is ampere meter inverse. ये सोचा important exam रे आसे short question. Similarly CG system रे ampere बदला ab ampere, meter बदला cm. तो in CG system the unit is ab ampere cm inverse. ठीक है, डायमेंशन कौन होबो, एठी मीटर अछि तो l to the power -1, करंट अछि दैट एरिया, तो द डायमेंशन इज l to the power -1 a to the power 1. ठीक है, आ मैंने डिस्कस करिथिले कि when a paramagnetic substance is placed in an external magnetic field, the dipoles which are aligned randomly inside the paramagnetic substance are aligned in a particular direction. After that poles are induced. ठीक है, and I एटा भी डिस्कस करथिले this the number of field lines inside the paramagnetic substance is more as compared to outside. So inside this paramagnetic substance the magnetic field strength is equal to sum of external plus internal. Magnetic field strength of the external magnetic field plus induced magnetic field. ठीक है, that is B is equal to mu naught into H plus mu naught into I. ठीक है, तो 80 I is positive, तो 8 positive, 8 मतलब positive, so that means this B is greater than this B naught कहि परियो. Okay, you can say this B is greater than B naught. In ferromagnetic substance they are strongly attracted by the magnet, बुझलो ना, तो they will have the dipoles align themselves along the direction of external magnetic field. तो 80 जो direction 80 मतलब same direction, तो 80 आइटा positive 80 मतलब positive, but the ferromagnetic substance they are strongly attracted by the magnet, so that's why large number of dipoles are aligned themselves along the direction of external magnetic field. So the magnetic field line or magnetic field strength inside the ferromagnetic substance is much more as compared to outside. ठीक है, okay, तो B is equal to B naught plus Bm. This is magnetic field strength inside this ferromagnetic substance is due to the external plus internal, but 80 that Bm is much more because due to the strong attraction large number of dipoles are aligned themselves along the direction of magnetic field, so that's why beta बहुत अधिक अधिक. If V is more, so we can say this is also more, so that's why B is greater than this is B naught. ठीक है, next is diamagnetic substance. They are repelled by this magnet. So when they are repelled, they produce, or the dipoles that is present inside the diamagnetic substance are aligned opposite to the direction of external magnetic field. They are aligned opposite to the direction of external magnetic field. इटी हमारा साउथ नॉर्थ होतला, तो एटी कोन हबो, since they are aligned opposite to the direction of external magnetic field, तो तारा opposite poles आसीबो. They will have opposite poles or the poles in opposite direction. ठीक है, तो that's why, तो एटी यदि आईटा पॉजिटिव नबा, since the dipoles are aligned opposite to the direction of external magnetic field, तो एटी आईटा मोर नेगेटिव. तो एटा हमरो एटा ए केस रा एटा नेगेटिव हो ठीक अछि ओके तो हमने एटा भी डिस्कस करथिले द नेट मैग्नेटिक फील्ड inside a diamagnetic substance is very less because of this opposite direction as compared to outside. So net magnetic field strength inside कौन होगा that is external minus induced ठीक है ओके तो ये मत हम कहि परिबा because negative काहे की हला because bm is equal that is mu naught into I तो एठी I टा negative so that's why so we can say this is that's why eta कौन हला that's why this bm is मैं negative नहीं लीजू ठीक है okay तो 8 ही तो we can say this net magnetic field strength is less than external magnetic field okay no because b is equal to b naught minus bm so we can say this b is less than that of b naught ठीक है the next term is magnetic permeability that is mu तो हमने permeability define करथिले it is the number of field lines that is allowed by the medium to pass through it again I'm saying it is the number of magnetic field lines allowed by the medium to pass through it यदि if it is air medium it is the number of field lines allowed by the air medium to pass through it ठीक है so in that case it is written mu naught permeability of air medium ठीक है our definition is that is magnetic permeability of a medium is the ability of the medium for the formation of magnetic field lines inside it it is the ability of the medium for the formation of magnetic field lines inside it okay again I just derive करथिले that is b naught or that is magnetic field produced by the solenoid is equal to that is mu naught into h because हमारा air medium थिला तो the magnetic field strength or magnetic flux density or the magnetic field strength produced by the solenoid is equal to mu naught into h so because the magnetic field lines are produced in air medium यदि आउ किछि मीडियम हे जो इन दैट केस b is equal to how much mu into h mu is the permeability of that medium तो mu केते होबो that is b by h तो permeability of the medium can also be defined as the ratio of magnetic field strength by magnetic intensity or magnetic flux density by magnetic intensity ठीक है permeability of a medium is defined as the ratio of magnetic flux density that is B inside magnetic substance to the magnetic intensity ठीक है तो any medium this B is equal to mu into h air medium it is mu naught into h तो हमें just discuss करिथिले for a paramagnetic substance this B is greater than B naught so if B is greater than B naught so we can say this mu is greater than mu naught similarly ferromagnetic substance रे हमें discuss करिथिले this B is greater than B naught so in that case we can say this mu is greater than mu naught in diamagnetic substance they are repelled by the magnet तो हमारा आस्थिला B is less than B naught तो mu कौन होगा less than mu naught ये सब जिनस दरकार पड़िबो for a short question in our board exam ठीक है unit and dimension of permeability okay हमें magnetic intensity रो छाड़ देथले unit and dimension तो magnetic intensity h is equal to n into I n is the number of turns per unit length तो तार unit कौन हो that is meter inverse ठीक है and I रो unit is ampere so in SI system the unit of h is ampere by meter or ampere meter inverse CG system रे एटा F ampere by cm ठीक है तो डायमेंशन कौन हो that is एटी अछि मीटर इनवर्स तो लेंथ इनवर्स and ampere hoche that is ठीक. Okay. Again we know that B is equal to mu H, or we can say air medium, this B naught is equal to mu naught into H. यदि हमें एटा नवा this mu is equal to B by H, तो B रो यूनिट is Tesla and H रो यूनिट बाहर that is ampere meter inverse. ठीक है. तो यूनिट ऑफ mu कितना है that is Tesla meter ampere inverse. ठीक है. And mu naught the same, that is Tesla meter ampere inverse, because both are same. 80 the B naught by H, both have same. Eta this is permeability of air medium, this is permeability of any medium. ठीक. And dimension is this m1 l1 t minus 2 a minus 2. our unit dimension exam रे आसे. ठीक है. Next is relative permeability, that is mu r. ठीक है. हमें इलेक्ट्रोस्टैटिक रे पढ़ी थिले, that is epsilon. It is permittivity of any medium. It is the number of electric field lines allowed by the medium to pass through it. How would it that is epsilon naught? It is the number of electric field lines allowed by the air medium to pass through it. That is epsilon naught. Then with the relation what is that epsilon is equal to epsilon naught into epsilon r. So this epsilon r is relative permittivity. It is a number which is assigned to different medium. It is, we can say this, it's a number which is assigned to different medium. So we can say permittivity of a medium is, it's that many times the number of field lines allowed by air medium. That if I say ER is 5, so we can say this is, so permittivity of this medium, let us say M1, is 5 times of epsilon naught, or 5 times the number of field lines allowed by air medium. यदि हमें गोटे मीडियम नवा M1 and से मीडियम रो ER यदि हम 5 नवा, तो we can say permittivity of that medium is 5 times of epsilon naught, or it allows 5 times the number of field lines allowed by air medium to pass through it. ठीक है. तो just like this हमारा magnetic field मध्य होची, that is permeability is equal to, permeability of any medium is equal to permeability of air medium into relative permeability. ठीक है. Just like this गोटे example नबो. तो let us say this is a air medium. Air medium गोटे magnet रखिबो. तो the magnetic field produce magnetic field lines. These magnetic field lines will travel in air medium. So let us say this air medium allows 5 number of field lines. 5 number of field lines to travel through it. So यदि 5टा field lines allow करछि, तो mu naught केता हो 5. तो let us consider कि हमें आउटे medium नबा. Let us say iron medium. And in this medium we place the same magnet. तो हमें देखिबा, यदि देखिबा कि एथरे 5000 number of field lines are produced. कहते 5000 number of field lines are produced. तो permeability of iron कहते हो, that is 5000, because it is the number of magnetic field lines mu is the number of magnetic field lines allowed by the medium. So this iron medium allows 5000 number of field lines. So mu of iron कहते हो, that is 5000. So we can say this 5000 किमती लिख परिए. This is 1000 into 5. So this is 1000 into 5 बदला में this is mu naught लिखी परिबा. So we can say this mu of iron is 1000 times the number of field lines allowed by air medium. This permeability of iron is 1000 times the number of field lines allowed by air medium. So we will give this constant, ये जो constant को हमें assign करिवा to iron. We will assign this number to iron medium. ठीक है, and एटा को लिखिवा this is mu r, relative permeability of iron. So this, ठीक है, तो relative permeability कौन? It's a number which is assigned to different medium. हमें relative permeability is simply a number which is assigned to different medium, and it represents, इटा कौन represent करूची? It represents that number of times the number of field lines allowed by air medium. Air medium जेतिकी allow करची, this medium is that number of times the number of field lines allowed by the medium. यदि आपको medium, let us say this is X medium, तो X medium जेति 25 number of field lines allow करूची, this is mu x, sorry, mu of X is suppose 25, so meaning we can say this is 5 into that is 5. So this is 5 into that is mu naught. So that means X has, we will assign this number 5 to medium X, and we will say that this medium X allows 5 times the number of field lines allowed by air medium. बुझिलो? तो हमरो general formula लिख परिया कौन? That is mu is equal to mu naught into mu r. हमरो iron medium पे कौन आस्तिला? That is mu of iron is equal to mu r of iron into mu naught. એટલે general formula कौन लिख परिया? That is mu is equal to mu naught into mu r. એટલે mu r केता होगा? Mu by mu naught. तो mu r is simply a number because जो divide करिया permeability रो unit dimension अछि, permeability of free space मतलब same unit dimension, जो divide करिया will get a constant, just like हम assign करते हैं example. तो mu r is the ratio of permeability of any medium to the permeability of air medium of free space. सीधे लिखा है जी, relative permeability is defined as the ratio of permeability of the medium to the permeability of free space. ठीक है, for vacuum this relative permeability is 1, for air medium it is slightly more than 1. ठीक है, for iron this relative permeability is more than 1000. हमें example लेते हैं 1000, its value is more than 1000. That means it allow more than 1000 times the number of field lines allowed by air medium. And हमें discuss करिथिले it has no unit, the unit not to dimension में nothing. So it is an important short question. Mu r has no unit and dimension. ठीक है, आउट बता. For this paramagnetic substance हमें discuss करिथिले this mu is greater than mu naught. तो mu जाएगा हम पके mu r into mu naught greater than mu naught. ठीक है, तो mu naught cancel, तो कौन आसला? Mu r is greater than 1. तो for paramagnetic substance relative permeability is greater than 1. ठीक है, for ferromagnetic substance this mu is greater than mu naught. तो mu naught into mu r is greater than mu naught. Mu naught कौटी जो तो आसला कौन? Mu r is greater than 1. Best example is iron. Iron is a ferromagnetic substance whose relative permeability is greater than 1000. So it is greater than 1. Next is dimagnetic substance. So in dimagnetic substance हम discuss करिथिले that is mu is less than mu naught. तो mu r into mu naught is less than mu naught. कौटी जो mu naught रहला कौन? Mu r is less than 1. ठीक है, ओके ये सब हमारा शॉर्ट क्वेश्चन है ऐसे. ठीक है, नेक्स्ट इज magnetic susceptibility. it is represented by the letter psi. ठीक है. So this susceptibility, magnetic susceptibility, is the ratio of intensity of magnetization to magnetic intensity. That is I by H. बुझलो? So it is defined as the ratio of intensity of magnetization to magnetic intensity. ठीक है? हमें unit of I बाहर करथिले, that is केते आसला हमरो ampere meter inverse. And H रो मध्ये unit बाहर करथिले, that is also ampere meter inverse. That means यार unit जहाँ यार unit मध्ये same. So that means psi, or that is magnetic susceptibility, is simply a constant having no unit and dimension. ठीक है? So it is a constant and it has no unit and dimension. Let us consider three magnetic substances, that is paramagnetic substance, ferro, and this diamagnetic substance, and let us keep all these three substances in an external magnetic field, that is B. So B is equal to mu H. So that means for all these three substances, when they are placed in the external magnetic field, H is constant. H is constant. ठीक है. And हमें जानिए a paramagnetic substance is attracted by the magnetic field. So when it is placed in the external magnetic field, the dipoles which are randomly distributed are now aligned in this direction, along the direction of external magnetic field. Again, these dipoles are aligned along the direction of external magnetic field. This is south north like this. Let us say this good dipole. This is south, this is north. So हमें जानिए the direction of dipole is magnetic dipole is from south to north. That's why each dipole को हमें these dipoles को हमें एमती भी represent कर परियो like this. इटा बुक रे दिया है. ठीक है. That means these dipoles which are randomly distributed now align along the direction of external magnetic field. तो आइटा मोरो positive आसियो. So that means I is positive, H is positive. You can say susceptibility is also positive for this paramagnetic substance. When this ferromagnetic substance are placed in the external magnetic field, we know that this ferromagnetic substance are strongly attracted by the external magnetic field, or ferromagnetic substance are strongly attracted to the magnet. That's why large number of dipoles are aligned along the direction of external magnetic field. So that's why this I is greater than 1. I is greater than 1. So H is constant, I is greater than 1. So we can say this is susceptibility of this ferromagnetic substance is greater than 1. And when a diamagnetic substance is placed in the external magnetic field, they are repelled by the magnet. So the dipoles which are present in the diamagnetic substance are aligned opposite to the direction of external magnetic field. This. That means item or negative. So this is negative by this positive is negative. So value of susceptibility lies between -1 to 0. Next is the relation between magnetic permeability and magnetic susceptibility. That is permeability, that is mu r, and this is susceptibility psi. Okay. So it is a 3 marks question which is asked in our board exam. So let us consider a linear magnetic substance. When it is placed in the external magnetic field, I discuss the magnetic field intensity inside this magnetic substance B is equal to B naught plus Bm. It is external magnetic field strength and induced magnetic field strength. And this B naught external magnetic field strength is equal to mu naught into H, and this induced magnetic field strength is equal to mu naught into I. So mu naught यदि बाहर कर दो H plus I. Again this from again this B magnetic field strength at any medium is equal to mu into H. ठीक है. And that is equal to mu naught H plus I. तो हमें चाहिए susceptibility is equal to I by h, तो I केते हबो susceptibility into h, तो एटी सब्स्टिट्यूट कर दो। ठीक अछि, तो हमर आसले कोन म्यू नॉट h प्लस psi into h। ठीक अछि, h टा कॉमन बाहर कर दो, रहले कोन 1 प्लस psi। ठीक अछि, it is mu is equal to mu naught into mu r, तो पुट करियो, तो एठी हमर म्यू नॉट कैंसल, h h कैंसल, तो रहला कोन mu r is equal to 1 plus psi। तो the relation between this is relative permeability and susceptibility is this is mu r is equal to 1 plus psi। ठीक है, এটা हमरो 3 मार्क्स क्वेश्चन बोर्ड रे आसे। ठीक है।